Hi everyone. The topic of today's lesson is finding areas of shaded regions. And you won't find this in your textbook because it's scattered throughout chapter 11, but what I did is combine all the shaded region problems and I made it into one lesson just like I did with the composite figures from yesterday. So let's go ahead and see what exactly we mean by a quote-unquote shaded region. So if you look at this figure here, we have a square, and we have this little shaded portion that is right in between the circle and the square. And these regions here are what we're looking for. We want to find the area. And it's quite simple to find that area. So here's our procedure. So what you're going to do is find the area of the entire figure. So what we would do is we would find the area of the entire square. So let me erase that right there. We're just going to shade in this entire square. And once we find that out, we are also going to find the area of this circle that's inscribed inside that square. And once we get those two measurements, we are going to subtract the area of the non-shaded region. So the circle is not shaded, so we're going to take that out, and we'll be left with the area of that shaded portion, that kind of curved triangular region. Not quite a triangle, but just a region that we can't directly find the area for with a formula. All right, so let's try this example out. So we are going to find the area of the shaded region here of this regular pentagon. And we have one large triangle with a base of 8 and a height of 5.5. If you'd like to consider that as two identical right triangles, you could do it like that, but that would probably be a little more work than just considering it as one triangle with a base of 8, because this is a regular polygon and a height of 5.5. So as you can see here, what we're going to do is find the area of this regular pentagon, which we know is found using the formula 1/2 SAN. So our side length is 8, our apothem length is 5.5, and we have 5 total sides. And as usual, if you multiply these values and divide those by 2, you should end up with 110. So now we're going to find the area of this non-shaded triangle right here. We're going to find that area, and that will be given by 1/2. And again, this distance is 8 because this is a regular polygon. And 1/2, 8 times 5.5 will give you 22. All right, so now we are going to take 110 and subtract 22. That leaves us with an area of 88 square feet. And I know there's other ways that you might be thinking we could come to that conclusion, but just to keep in line with the whole finding the area of the entire figure and taking out the area of the non-shaded portion, this is the strategy that we'd want to use. All right, so I want you to apply that logic to the problem we looked at when we wrote down the procedure of how to find a shaded area. So there's a large square here, and inscribed in that square is a circle. So find the area of the square and the circle and subtract. And please pause the video for a moment and try that out, and check back for the answer when you are ready. All right, so hopefully you gave that a shot. So we are going to find the area of this entire square. Now, for my area of a square, I have base times height. So there are other formulas for squares, notably area equals s squared. But that's just another formula that I don't want you to have to just memorize. So we're just going to stick with that rectangle formula, and 40 times 40 gives you 1600. Now, what is the radius? Well, if you go from the center to the edge, we know that radius is 20. So pi times 20 squared is 400 pi. Now, if you would like to leave it in terms of pi, and then type this in your calculator, that's another option. You could actually write 1600 minus 400 pi in your calculator, and then you will end up with this result, 343.36 square meters. Okay, so again, if you'd like to do it like this, you'd like to write your circle area in exact form, as we call it, and type this directly in your calculator, you can save yourself a little bit of work having to write this down and rewrite it. And you get 343.36 rounded to the nearest hundredths place. As always, this is area. Don't forget your square units. Here it's square meters. All right, so here's another example. Find the area of the shaded region. So as you can see, this portion in blue here that I'm just coloring over, it's a very interesting looking shape that we cannot directly find using any formula. But what we do know is we know the area formula for a circle. So what we're going to do first is we're going to find the area of the big blue circle here, or just the entire circle, and that's found using pi r squared. Now notice I have 6, so let's take a look at why the radius is 6. So if the radius of the small circle is 3, so if I draw that radius this way, and remember here is our center point, I know that's a distance of 3. Now if I travel one more radius this way, I'll have distance of 3 here and a distance of 3 here, and together that makes a radius of 6. Now this is for the big circle, so I have pi times 6 squared. Now notice I left the answer in exact form. You'll often find out that it's much easier to leave it in the exact form until the very end. So here, especially when you're finding areas of a lot of circles, in this case there's 3 different circles, it's better to leave everything in pi, and then you can multiply it out at the end to get your answer to the nearest hundredths place. Alright, so now for the area of the small circle, yes, you are looking at the radius of the smaller circle. Radius of that small circle is 3. So pi times 3 squared is 9 pi. Now you have 2 copies of this circle. So yes, you are going to have to multiply that by 2. This is one circle. So we're going to have to multiply that by 2. And you'll see on the next slide, we do eventually do that. So here's our final area of our shaded region. So we take the entire area, which is 36 pi, and we're going to subtract 2 times 9 pi, because remember, each of these circles has an area of 9 pi, which is approximately 28.33 or so. Now you take away the area of those 2 circles, which is 18 pi, you will be left with 18 pi. And now here is where you can go ahead and actually use your pi button on your calculator, and you'll end up with 56.66 square meters for your area of your shaded region. So that part in light blue will be 56.66. All right, so please pause the video here, and I want you to give this problem a shot. So check back when you are finished, and we'll go over the solution. All right, so we are finding the area of the shaded region again, the light blue portion in between those 4 circles. So we're going to start off by finding the area of the square. Remember, that's base times height, or if you'd like, you can use s squared, which would give you 20 squared. Regardless of what formula you use, you should get 400 for your total area. So again, the entire shape takes up 400 square units. So if I colored this in, I'd have 400 square inches. Now that's too much area. We've got to take out the area of the 4 circles. And that's where the other calculations come in. So pi times r squared is the area of one single circle. And notice I have a radius of 5. So let's talk about why that's so. So if it's 20 from end to end here, we know that this radius of the smaller circle is 5, because if I write 5 repeatedly here, you'll notice 5 plus 5 plus 5 plus 5 makes 20. So that makes the radius of one small circle 5 inches. So again, I left this in exact form because, like I said, oftentimes you'll notice it's much easier to leave this in the exact form, because once you multiply 25 times pi, you're going to probably get an ugly decimal that you have to deal with. So here, I wrote 400, and I'm going to take away 4 times 25 pi. 4 times 25 is 100 pi. 400 minus 100 pi. 100 pi, by the way, is about 314.159. Gives you an approximate answer of 85.84 square inches. All right, we're going to try out one last problem before I let you go. So here is our final example. So here we're going to find the area of this shaded region. And again, rounding to the nearest hundredths if necessary, and it will be necessary here. So notice, if I draw a vertical segment here, I'm going to get a fully enclosed rectangle. Now, it looks like a rectangle that's just had a big bite taken out of it. Now, the bite is in the shape of a perfect semicircle. Okay, we've got that semicircle right here. All right, so as before, you're going to find the area of the entire rectangle, and we're going to find the area of this semicircle, and then we're going to subtract this non-shaded area away so we can find the area of this leftover piece. So here's our first step. Area of the rectangle is base times height. It's 14 times 6. That's going to give us 84 square inches. Now remember, that's too much because that includes this area. So 84 is too large of an answer. Now we're going to find the area of this semicircle here using the formula 1/2 pi times r squared. So our radius is 3 because if you look at the opposite side, the height of this rectangle is 6, which would correspond to a radius of 3. So 1/2 pi times 3 squared. This would be 1/2 of 9 pi. So if you wanted to leave this in exact form, you could. You could write this as 4.5 pi. And as before, you can take the entire 84 and just subtract away 4.5 pi. So it's totally up to you how you want to do this. This is already approximated for us. And our shaded area calculation is 84 minus that 4.5 pi, which will give us about 69.86 square inches. So be careful because you did a problem just like this in yesterday's lesson where you had to find areas of compound or composite figures that look like this. So you actually had a shape that did this. And in that case, when it's not a shaded region problem, you would have to find the area of this rectangle. You'd find the area of that full rectangle, and then you would add the area of this semicircle. So be very careful because the procedure is almost the same, except in the shaded region problems, you are subtracting. All right, so that does it for today. Thank you, guys.